Question number 96. Select the incorrect statement regarding Krebs cycle. First option, the FAD molecule is reduced to FADH2 during the conversion of succinic acid to fumaric acid. Second, substrate level phosphorylation occurs at one step only. Third, succinate dehydrogenase is found attached to the inner mitochondrial membrane. Fourth, the cycle starts with condensation of acetyl coenzyme A with citric acid. You have to choose the incorrect statement regarding the Krebs cycle. Here it is shown the Krebs cycle or the citric acid cycle. Now see the statements one by one. That the FAD molecule is reduced to FADH2 during the conversion of succinic acid to the fumaric acid. It is true that FADH2 is produced during the conversion of succinic acid to the fumaric acid. So this is true. Second, substrate level phosphorylation occurs at one step only. It is also correct that substrate level phosphorylation means direct ATP formation takes place at a single step, and that step is shown over here. Here, direct ATP production takes place. So this is also correct. Third, succinate dehydrogenase is found attached to the inner mitochondrial membrane. This enzyme is helpful in Krebs cycle. All the enzymes of Krebs cycle are present in the matrix except the succinate dehydrogenase. It is found attached to the inner mitochondrial membrane. So it is also correct. Now the last statement, that the Krebs cycle starts with the condensation of acetyl coenzyme A with the citric acid. No, the condensation of acetyl coenzyme A with the OAA or the oxaloacetic acid takes place to produce the citric acid. So this statement is wrong. So the correct option for the given question is option number 4. Let's move to the next question. Question number 97. The common intermediate among fats, proteins and carbohydrates during aerobic respiration mediated breakdown is first option pyruvate acid, second acetyl coenzyme A, third dihydroxyacetone phosphate, and fourth glucose 6-phosphate. See here in this figure it is shown that the fats, carbohydrates and proteins undergo respiration and their breakdown leads to the formation of a common compound which is called acetyl coenzyme A, which enters into the Krebs cycle. So the common intermediate amongst fats, proteins and carbohydrates is acetyl coenzyme A, which is a 2-carbon molecule. So the correct option for the given question is option number 2. Let's move on to the next question. Question number 98. Read the following statements and select the correct option. Statement A. During complete oxidation of pyruvate or pyruvic acid, CO2 is released at 3 steps. Statement B. For an anaerobic respiration, the respiratory quotient RQ will be infinite. First option only A is incorrect. Second only B is incorrect. Third both A and B are incorrect. Fourth both A and B are correct. So you have to check whether these statements are correct or incorrect. See the statement A. During complete oxidation of pyruvic acid, CO2 is released at 3 steps. It is very true. Why? Because pyruvic acid is a 3-carbon compound, and during the complete oxidation of pyruvate, these 3-carbon compounds should be converted into 3 molecules of CO2. So this is true. Statement B. For an anaerobic respiration, the respiratory quotient will be infinite. What is respiratory quotient? Respiratory quotient can be defined as the volume of CO2 evolved to the volume of O2 consumed. And in an aerobic respiration, the CO2 evolved will be something, but O2 consumption will be 0. So anything upon 0 will lead to the infinite condition. So it will be infinite. So in anaerobic respiration, the RQ will be infinite. It is also correct. So the correct option for the given question is option number 4. Let's see the next question. Question number 99. Select the molecules which are products of fermentation of glucose by yeast. A. C2H5OH, which is ethyl alcohol. B. ATP. C. C12H22O11, which is a sugar. D. O2. E. CO2. First option only A. Second A, B and D. Third A, B and E. Fourth only A and C. Okay, so first is the glucose is converted into pyruvic acid during the glycolysis, and this pyruvic acid is converted into ethyl alcohol plus CO2 plus ATP during fermentation. So this step is glycolysis. So this is complete alcoholic fermentation. So during alcoholic fermentation by yeast, ethyl alcohol, CO2 and ATP molecules are produced. Oxygen and the sugar are not produced. By analyzing the option, you can say the correct option for the given question is option number 3. Let's move to the next question. Question number 100. How many ATP molecules will be produced from the complete oxidation of one molecule of acetyl coenzyme A? First option 12, second option 14, third option 36, fourth option 38. How many ATP molecules will be produced from the complete oxidation of one molecule of acetyl coenzyme A? Complete oxidation of acetyl coenzyme A will take place in the mitochondria. And this is the Krebs cycle which is shown over here. You must remember this figure is from your NCERT. Now calculate the ATP molecules from one molecule of acetyl coenzyme A. If this one acetyl coenzyme A enters into the Krebs cycle, then 3 NADH plus H plus molecules are produced, 1 FADH2 and 1 direct substrate level phosphorylation occurs, means one direct ATP is also produced. So the net gain from one molecule of acetyl coenzyme A in Krebs cycle or in complete oxidation is 3 molecules of NADH plus H plus, 1 molecule of FADH2 and 1 molecule of ATP. Now, these 3 molecules of NADH will produce how many ATP? You should know that 1 molecule of NADH produces 3 molecules of ATP in the mitochondria. So, this will lead to production of 3 into 3, that is 9 ATP. 1 FADH2 will produce 2 ATP. And this 1 ATP will be 1 ATP only. So, total is 9 plus 2, 11 plus 1, 12. So, from 1 molecule of acetyl coenzyme A, 12 molecules of ATP will be produced. So, the correct option for the given question is option number 1. Let's move on to the next question.